Okay. So, last class we have derived that for a reciprocal electrostatic transducer, that S dash is equal to S plus phi square by C 0, phi square by C 0, and we said that ZMO is equal to Rm plus J omega m minus S dash by omega, and S dash is equal to this one. Okay. Now, if I consider for a electrostatic transducer, if I said that this omega is less than much less than this omega is much less than S by m. What is the meaning? The meaning is that the frequency of operation, just a minute, the frequency of operation root over of S by m. So, I said that if I operate the electrostatic transducer below the, this is the S by m is nothing, S is the stiffness of the diaphragm, m is the mass of the diaphragm. So, if it is said that the omega is much below the root over of S by m, that means the operating frequency is much below the resonant frequency, and the mechanical resistance Rm is much less than the S by omega. That means that I should not housing that diaphragm such a mechanical resistance that it does not vibrate. So, that means that Rm should be very low and the operating frequency should be much less than the resonant frequency of the diaphragm. So, if I consider these two limitation, then this will become, so then what is ZMS? ZMS is nothing but a 1 minus Kc square into ZMO. Okay. So, I can say 1 minus Kc square is equal to ZMS by ZMO. I know what is ZMS and what is ZMO. If I put those two value, what is ZMO? I know that ZMO, we have ZMO is nothing but a, this one is ZMO. Now, what is ZMS? ZMS is nothing but a Rm plus J omega m minus S by omega. If I put the value of ZMS, and so I put the value of ZMS is nothing but a Rm plus J omega m minus S by omega divided by ZMO. What is ZMO? Rm plus J omega m minus S dash by omega. If I simplify that two things with the condition that this is the condition, then 1 minus Kc square, or I can say the Kc square will be, then Kc square will become 1 minus ZMS by ZMO, which will become 1 minus Rm plus J omega m minus S by omega divided by Rm plus J omega m minus S dash by omega. Within these two limitation, Kc square will approximately come 1 minus S by S dash. So, if the electrical capacitance is equivalent to short circuit mechanical stiffness, we have studied that S and C is a relationship, the C is equal to 1 by S or S is equal to 1 by C. So, if the electrical capacitance equivalent to short circuit mechanical stiffness, then I can say the C is nothing but a phi square by S. Phi square is the transformation coefficient, okay, to convert to electrical side. See, here we studied that equivalence, electrical capacitance is equivalent to 1 by S. Now, if the electrical to mechanical transformation coefficient is phi square, So, it is C is nothing but a phi square s. If C is nothing but a phi square s, then I can write the Kc square is nothing but a C by C plus C0, because S is equal S dash is S plus phi square by C0 and S is nothing but a 1 by C. So, I can write C by C plus C0. So, coupling coefficient Kc square is nothing but a C by 1 plus C plus C0. This means this is the ratio. What is Kc square means? This is the ratio of stored mechanical energy to the total energy. Stored mechanical energy to the total. The ratio between the stored mechanical energy to the total energy. Okay. So, this is the basic derived principle for reciprocal transducer or electrostatic transducer. Okay. Now, we go for another kind of transducer which is in the anti-reciprocal. What is anti-reciprocal transducer? Where TME and TME, TEM electrical to mechanical and is minus is equal to mechanical to electrical. Okay. So, anti-reciprocal transducer. Example is moving coil transducer. Let us I draw a moving coil transducer. If I draw, it will be nothing but a magnetic field. So, let us a magnetic field, come here, then I can draw it here and here, then I can draw here, here and here. So, this is the magnet, and on the magnet I housing a moving coil. Okay. The coil is connected to the coil is covered by a dome, and I can say this is the diaphragm. Okay. So, this is called, this coil is called voice coil. This is nothing but a voice coil, and this is nothing but a suspension, and this is N, this is S, and this is a magnet. Okay. And this is called dust cover or dome. Dome and diaphragm. Okay. This is dome, and so there is a suspension, diaphragm is suspended, diaphragm and dome. Okay. So, if you see in any normal moving coil loudspeaker, I will show you in the next class that normal moving coil loudspeaker. So, there is a magnet, on the magnet there is a coil is suspended, and the coil is connected to the diaphragm, if you see, and if I apply a voltage on the coil, if I apply a alternative voltage on the coil, then the coil will move, or if I move the coil, a current will be induced. So, both way it is this transduction is possible. So, what is the basic principle? Basic principle is that what is first of all, what is the coil electrical impedance? Why it is called electrical coil? If I not allow the movement of the diaphragm, what I said, the mechanically I am not allowing the movement of the diaphragm, that means diaphragm is blocked. So, then the electrical impedance of the coil ZEB, blocked electrical impedance, is nothing but a R0 plus j omega L0. R0 is the resistance of the coil and L0 is the inductance of the coil. So, if I not allow the movement of the diaphragm, so I fix the movement of the diaphragm, then that means I block the diaphragm, not allowed to move it, then blocked electrical impedance is nothing but a R0 plus j omega L0. Okay. Now, if I say that I allow a I current on the coil, if I pass I current on the coil, then what will happen? Depending on the magnetic field, so there is a magnetic field, if the current passes through the coil, a force will be induced. So that force is nothing but a F is equal to B cross I into L, where I is the current, B is the magnetic field strength and L is the length of the coil. Now, if B cross I is a vector, so I take the positive direction only, then I write B I L is the force. So, if I apply a I current, then this force will be acting on the diaphragm, because the coil is attached to the diaphragm. So, this force will be acting on the diaphragm. Okay. Then, if it is there, then what is the mechanical impedance? If I say mechanical impedance, how do I find out the mechanical impedance? From the diaphragm only. So, if I open the electrical circuits, that means I have not disturbed that mechanical system with an applied electrical voltage, then ZMO mechanical open circuit mechanical impedance is nothing but a Rm plus J omega m minus S by omega. So, it is nothing but a diaphragm is nothing but a spring mass system. It is suspended with a mechanical resistance Rm and mass of the diaphragm is m and stiffness of the diaphragm is S. So, it is nothing but a ZMO Rm plus J omega m minus S by omega. So, these two things I got, and I got block. If I apply a I current now, then I got a force, acting force F is nothing but a BLI. BLI. Okay. Now, if we see, if I apply a I current, diaphragm start movement. If I want to stop that movement, then I have to apply another force. Let's the force is acting on this force is acting on the force, the magnetic due to the I current, that force want to move the diaphragm in this direction. So, the direction of the force in this direction. Now, if I want to don't allow the movement of the diaphragm, then I require an equal amount of the force in reverse direction to hold the diaphragm. So, I can say the total electrical voltage or total force acting on the diaphragm in equilibrium condition is nothing but a minus BLI plus ZMO into U. If the particle velocity, so the to oppose the electrical force, I require this force, or I can say the resultant force is nothing but I require this force, and let us U is the particle velocity of the diaphragm, then it is nothing but a minus BLI into ZMO into U. Okay. So, this is the one canonical equation of anti-reciprocal transduction. Now, I want to derive that reverse thing. Reverse things means I apply a force on the diaphragm, the motion will be there, then the spring will, the coil will be moved. If coil moved in a magnetic field, then a current will be, a voltage will be induced on the coil. Okay. So, what is the voltage will be induced? So, I can say that if the motion is U, then the induced voltage will be BLU, the velocity of the diaphragm is U, then the induced voltage on the coil will be BLU, who will oppose the electrical voltage. So, I can write V is equal to BLU plus ZEB into I. So, this is the canonical equation 2. So, force minus BLI plus ZMO into U, voltage BLU plus ZDB into I, which is the canonical equation of that anti-reciprocal transducer. What is there? Canonical equation of the anti-reciprocal transducer. If you see the slides, this is nothing but a ZDB into I plus BLU. So, I can write phi m is nothing but a BL. If you see this equation, so ZDB into I plus phi m, here phi m is nothing but a BLU and here it is minus BLU. So, canonical equation supports. So, phi m is nothing but a B into L, phi m is nothing but a B into L, which is real and constant. For the magnetic B is the field, once the magnet is fixed, I am not changing the magnet. So, B is fixed. Once I putting the coil will be the fixed length. So, I cannot change the L after that. So, B and L, product of B L N is a real and constant. Okay. Now, this is the phi m. So, induced. So, now can I say what should be the equivalent circuits? If this is the equation, so what should the equivalent circuits of this transducer? Equivalent electrical circuits of this transducer. So, I want to draw it. So, what is there? I said I apply a V voltage here. Okay. Now, what is ZDB? Is nothing but a R0 plus J omega L0. So, R and L in series. Okay. Then anti-reciprocal transducer equivalent circuits. Phi square, if you see these slides, ZDB, R0 and L0 in series. Then I require a phi square YMO. Okay. And then this is nothing but a phi m U and this is nothing but a F by phi m. Okay. So, what is phi square YMO? Phi square YMO is nothing but a phi square by ZMO. Admittance becomes, if it is impedance, then YMO is nothing but a 1 by ZMO. So, I can say that okay, in case of a ZMO, ZMO is nothing but a Rm plus J omega m minus S by omega. So, phi square YMO can be thought as a resistance, capacitance and inductance spring mass system. If we solve this equation, this will come, this is Rm, this is Cm, this is Lm. Then Rm will be becomes phi square m divided by this R, let us ask capital M, write capital M, because Rm I have written already, L capital. So, R capital M is nothing but a phi square by this Rm and Lm, L capital M will be phi m square by S. In admittance, if it is capacitance, then it becomes inductance. So, Lm, since S is equivalent to capacitance, then here since it is admittance YMO, it becomes capacitance. So, phi square Lm is nothing but a phi m square by S and Cm will be m by mass by phi m square. This is the equivalent circuits of the anti-reciprocal transducer. Okay. So, how it is work? If I apply a electrical voltage, then coil will be in motion. If I apply a pressure in diaphragm, coil will be in the motion, and it induces a voltage. Okay. So, what I have to find out? I have to find out Kc, or here instead of anti-reciprocal transducer it is Km. Okay. So, I have to find out what should be the Km. Okay. Let us find out. Now, ZMO I know. What I do not know, ZMS. ZMO means open circuit mechanical impedance I know. What is the closed circuit or short circuit? If I apply a current, that means I connect the electrical circuits, then what should be the mechanical impedance? So, ZMS is nothing but a ZMO as per these slides. If you see these slides, ZMS is nothing but a ZMO plus phi m square divided by ZdB. What is ZMO? Rm plus j omega m minus s by omega. What is ZdB? Phi m square divided by ZdB is nothing but a R0 plus j omega L0. J omega L0. If I simplify these things, what I will get? I will get ZMS is equal to, I can say is nothing, I can say it, and then I have to find out. So, ZMO, so ZMS will be Rm plus j omega m minus s plus phi m square divided by L0 whole divided by omega. This will come. If I consider if R0 is much lower than omega L0. If R0 is much lower than omega L0, then I can remove this R0. So, I can say it is nothing but a j upside j will be multiplied. So, it is nothing but a s plus phi m square by L0 divided by omega into this. Okay. Now, if I want to find out Km, what is Km? So, I can say Km is nothing but a 1 minus ZMO, Km square is nothing but a 1 minus ZMO divided by ZMS. ZMO divided by ZMS. So, Km square will become same as reciprocal transducer is nothing but a Lm by Lm plus L0. Like see Lm by Lm plus L0. Same case I can say the this is the ratio, this is nothing but a Km, this is nothing but a ratio of the mechanical energy divided by the total energy. Okay. So, this is the theory for anti-reciprocal transducer. Okay. Next class I will go for the transformer design, transducer design. Okay. Sorry.